Alright, good morning children, welcome to school. This is going to be a very short video about solving and creating linear systems of equations. This is a topic we have done in the classroom, but this is also an assignment that was given on Google Classroom, and I've seen some people struggle with this. So I'm just going to go ahead and solve a representative problem of this assignment that will definitely clear things up for you. That said, let's go ahead and jump right in. In this problem, we talk about the Celluloid Cinema that sold 150 tickets to a movie. Some of these were child tickets and the rest were adult tickets. A child ticket costs $7.75 and an adult ticket costs $10.25. If the cinema sold $1,470 worth of tickets, which system of equations could be used to determine how many adult tickets A and how many child tickets C were sold? Now this is a classic example where we have two unknowns, we obviously have two prices, and we have two situations that we need to set up. One that talks about quantity and another one that talks about price. Okay, so what are the two things we do not know, right? We do not know A, which is the number of adults. Okay, we also do not know C, which is the number of children. Okay, so let's write that there. The second thing we want to go ahead and do is set up a linear equation that talks about the quantity. Okay, so how many adults? Well, we don't know, so let's put A, plus how many children? We don't know, let's put C, and in total there were 150 tickets. Okay, now this line talks about quantity. All right, the next line, you guessed it, is going to talk about price. Okay, so let's set that accordingly. Alright, so how much is an adult ticket? An adult ticket is $10.25 plus the child ticket or children ticket is $7.75, and that is going to equal $1,470 because that's how much they sold. Now, in order to solve this system, we need to use elimination. You could actually also use substitution, but that method we haven't seen inside our class, so let's go ahead and use elimination. In order to do that, you need to have coefficients in front of all of your variables. I put a 1 there because if you multiply 1 times anything, you get exactly the same thing. So it was as if that one was always there, had been there all along. Next thing you want to do is go ahead and put a parentheses outside of both lines, right? And in order to eliminate, we need to find factors that basically will get rid of one of the variables when you add the two lines. Now, you could find, like two numbers that that would make that work, but one trick you can use is just switch the numbers. So put 10.25 right here and then put a -1. Okay, now one question I get a lot is, how do you know which one gets the negative? It really doesn't matter which one gets the negative as long as one is positive and one is negative. Okay, all right, so now let's go ahead and distribute. So we distribute here, and we are going to get, I'm going to write in this blue. So 1025 times 1 is obviously going to be the same thing, 10.25a plus 10.25c equals, what is 150 times 10.25? So let's go ahead and type that. 150 times 10.25 is 1,537.5. Okay, And then we're gonna go ahead and distribute the other -1 right here. So we're gonna go ahead and get -10.25 A minus 7.75 C, and then minus 1470. Okay, what are we gonna go ahead and do? We're gonna add, okay, our two lines, okay, or two equations. So the next thing is, well, 10.25a plus -10.25a is gonna go to 0, so you just eliminate that. And then we're gonna do 10.25 plus -7.75. That is gonna give us 2.5. 2.5 equals, alright. Then we have the last one that's going to give, 2.5c. Okay, the last one is 1537.50 plus -1470, and that will give us 67.5. Now in order to solve for c, right, we need to divide both by 2.5. So we get c equals 67.5 divided by 2.5, and that will give us 27 children. Okay, now we know that the number of adults plus the number of children, which is this line right here, a plus c equals 150, right? So if we have a plus 27 children, we can solve very easily for the number of adults. So the number of adults is going to be 123. Okay, adults. Alright, so we finally answered the question. We set up a linear system of equations that describes our situation. We listed two unknowns, one that deals with quantity and price, right? And we also used the process of switching the leading coefficients, one positive and one negative, in order to eliminate one of the variables. First we solved for the number of children, and then we plugged that number of children into one of the equations to find the number of adults. Hopefully this video was helpful to you, and until next time.